Good day, ladies and gentlemen. My name is Dr. Siziwe Koba. I am a facilitator at Forced Discovery Center ReVEL facility. Now, before I get into what I'll be showing you, let me firstly give you a quick background of what ReVEL is. ReVEL stands for Remote and Virtual Education Laboratory. This is the first of its kind virtual laboratory in South Africa. The facility offers several benefits, including using coding and robotics, thus enabling students to interact with peers from over 20 universities around the world on experimentations to address local and national imperatives in science, technology, engineering, and mathematics. ReVEL advances teaching and learning to address some technological inadequacies in our communities. ReVEL also gives University of Hare researchers access to various online research equipment worldwide. ReVEL users are able to access the facility wherever and whenever via the internet. Welcome to Labsland, University of Hare. This is where you find all our ultra-concurrent experiments. Today I will be showing you an experiment called water heating and cooling curves. Before I show you the experiment, let me quickly give you a background of the experiment. The aim of this experiment is to investigate the details of phase change, particularly the temperature changes that are observed when ice is subjected to high and low heat. A heating curve graphically represents the phase transitions that water undergoes as heat is added. A cooling curve is the reverse of heating curve. It shows the effect that a decreasing temperature has on the water. As energy flows into the ice, the random vibrations of the water molecules increase as the temperature rises. Eventually, the molecules become so energetic that they break loose from their latest positions and change from solid to liquid. For this investigation, it is very important to clearly identify the dependent and independent variable is the time interval that is chosen between recording the temperature of the water, that it depends on the amount of heat supplied by the hot plate. The amount of hot plate increases with time. Another dependent variable is the phase of water. It depends on the temperature and the time the hot plate to be adjusted at a certain rate and not be changed. The rate of heating is controlled and the mass of water is kept constant during this experiment. However, due to vaporization of water, there would be a slight loss of water as it is heated. Now we can start with the experiment. We click on Access. After clicking on Access, you will be redirected to another page, and then we click on Configuration. After you click on Configuration, you're going to see the experiments. And then you'll choose which experiment you want. We are going to start with the heating. Select the experiment that you want. Then you scroll down. You're going to see two options, whether you want to start with low heat or with high heat. For the sake of this demonstration, we are going to start with high heat. After you click on high heat, you scroll down to Start Observing. Immediately after you click on Start Observing, you are going to see two camera screens. The first one on your left is the process camera. The process camera captures what happens to the ice as it is being heated, what phases the ice goes through as it is being heated. So we have here a hot plate that we use to heat the ice at maximum temperature. We have a beaker with crushed ice, and we have a thermometer inserted onto the ice. Now the thermometer helps us in recording the temperature of the ice as it is being heated. Over here you have different speeds that you can choose to play the video in. So for the sake of this demonstration, we are going to choose 5. We click on 5. Now if you look at the ice, it is slowly melting. And let's look at the temperature. So the temperature is going up. It is steady going up. Let's look at the ice again. The ice is melting. The ice is melting. Let's look at the temperature. Temperature is still going up. The temperature is still going up. It's now on 67 degrees. And you can see now it's completely liquid. So the ice has changed phases from solid to liquid. Now these are some of the observations that the learners are expected to take note of. Now the temperature is on 91 degrees and it's starting to boil. You can see some vapor in there. Now it's on 98 and it's completely boiling. Now let's go back to configuration. The second part of the experiment that I'm going to show you is cooling. We select cooling. After selecting cooling, we start observing. Just like in the previous experiment, you are going to see 2 camera screens. The first one is your process screen, but the difference now is that on the process screen we have a bucket of ice, a beaker with hot water, and a thermometer. So now the thermometer is going to measure the temperature of the ice as it is being cooled. Let's start observing. The speed that we're going to choose is 5. Okay, let's look on. So on the left, there's nothing much to see. The thermometer screen tells us everything that we need to know. As you can see, the temperature of the water is going down. Now at the end of this experiment, learners are expected to plot a graph of time versus temperature. The time it took for the water to cool. Thank you.